With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
The question is to find the integration of x square divided by x sin x plus cos x whole square dx. Here if we let the value of our I to be equal to integration of x square dx divided by x into sin x plus cos x whole square. Now here what we will do is we will multiply and divide this by cos x. We see that it will have no effect. But now we can write this to be equal to integration of, we can write x cos x to be as 1 and we are now left with 1x and 1 upon cos x is secant x. So this will be x into secant x dx divided by x sin x plus cos x whole square. Here we will integrate this by parts method which says integration of u into v is equal to u into integration of v minus integration of du into integration of v. Here we will let this x cos x and the denominator to be our function second and we will let x secant x to be our first function. We are doing this because it is easier to differentiate our this one and easier to integrate this one. Therefore our I will be equal to x into secant x will come as it is integration of x cos x dx divided by x into sin x plus cos x whole square minus integration of, now we will differentiate our x secant x. Here we will have to apply the product rule which says u into v differentiation is equal to u into v differentiation plus v into u differentiation. So differentiation of x will be 1. So we will have secant x plus, now x will come as it is and differentiation of secant x is secant x into tan x and this is multiplied by the integration of x cos x dx divided by x into sin x plus cos x whole square. Firstly, we will only integrate this part. Here we can let this to be I1, that is integration of x cos x dx divided by x into sin x plus cos x whole square. Now here what we will do is if we put the value of our denominator, that is x sin x plus cos x to be equal to t, differentiating both the sides. Here also we will apply this formula. This will be equal to sin x plus x cos x plus this will become minus of sin x into dx is equal to dt. This and this will get cancelled. So therefore the value of x cos x dx will be equal to dt. So we can substitute our numerator. Therefore our I1 will be equal to integration of dt divided by t square, which will be equal to t to the power minus 2 plus 1 divided by minus 2 plus 1 plus of c, that will be minus 1 upon t plus c. We will put back the value of t over here, so it will be equal to minus 1 upon x sin x plus of cos x plus c. So now we can put this value back in our main integral. Now our I will be equal to minus x into secant x divided by x into sin x plus cos x minus, now here we see that we can take secant x to be common. So we will have integration of secant x into 1 plus x into tan x divided by this term. Here we can take minus to be out, so it will become plus x sin x plus cos x plus of c. So for once we will only consider this part, okay? So what we will do is we will convert all of these into sin and cos. So this will become 1 upon cos x multiplied by 1 plus x sin x divided by cos x and this is whole divided by x sin x plus of cos x. Here what we will do is if we take the LCM, we see that this will become cos x plus x sin x divided by cos into cos will become cos square x and this is multiplied by x sin x plus cos x. Here we see that this and this term is same, so it will cancel out and here we are only left with 1 upon cos square x. So if we put this value back here, our I will now be equal to minus x secant x divided by x into sin x plus cos x plus we have here integration of 1 upon cos is secant, so this will become secant square x dx plus c, which will be equal to minus x secant x divided by x into sin x plus cos x plus, now integration of secant is secant square is tan x So it will have tan x plus c. Now we see that in our options we have all these terms into sine and cos. So we will have to convert them also. So this will be minus x upon cos x multiplied by x sine x plus cos x will come as it is, and this can be written as plus sine x divided by cos x plus c. If we take the LCM, this will be minus x plus sine x multiplied by x sine x plus cos x, and we have our LCM to be x sine x plus cos x, and this is multiplied by cos x plus c will come as it is, which will be equal to, now from these both terms if we take x to be common, we see that here we will have sine square x minus 1, and we are multiplying this also, so this will be cos x multiplied by sine x divided by x sine x plus cos x multiplied by cos x plus c. Now there is the identity of sine square theta plus cos square theta, that it is equal to 1. So if we apply this over here, our I will be equal to, this will be minus of cos square x multiplied by x plus cos x sine x divided by x sine x plus cos x multiplied by cos x plus c. We can see that we can cancel one cos from both numerator and denominator. So this value will become sine x minus x times of cos x divided by x sine x plus of cos x plus integration constant c. So therefore this is the value of our integral. And now if we look at our options, our option number 2 will be the correct answer.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.